to enter edit mode. From the horizon line, I offset copy by 1 meters, and then another offset of 2 meters from the middle selection. For the horizontal line, I use the line under the slab as a reference. Delete unnecessary line and apply flat. This creates a U-shaped valve. Now we need to create the roof parapet, and for this we use a valve. Instead of assigning a level as the top constraint, we set a fixed height of 1.10 meters. Then we switch to our camera view. Now we can move on the facade form and surface design. For shaping the facade scheme, we can go to the Architectural tab, choose a component and the model in place. Using tools like Extrude and the other available options, we can create different facade elements and surface. The first thing we need to do is go to the set working plan and define where the base of our extrude is going to be. In this step, we want to create the sheet elements that's wrapped around this opening. So we set the work plan on this wall. Then, use an extrude and the edge of this geometry as a reference. We draw the metal sheet. After picking this line, we give the sheet a thickness using offset. Connect all the line with the fillet and then confirm the sketch. Finally, from the extrusion setting, we define the depth of the elements. Since the extrusion starts from the surface and we want it to start from behind the wall, we need to move the extrusion start inward by the wall thickness. This way, the extrusion starts from the back of the wall. The wall thickness here is 20 centimeters. The next step is modeling the flower box. We set the work plan on the balcony floors, then go to Components and use Extrude, again to draw the flower box baseline. Here, I'm working with 2 parameters to match the flower box exactly to the reference image. The first one is extrusion start, which controls the distance between the flower box and the balcony floors. The second parameter is extrusion, which defines the height of the flower box itself. By adjusting these 2 values together, I find the tone the model until it's closely matched the proportion and position shown in the image. In the next step, we need to adjust the second floor wall, and our 3D model is currently fully glazed. But in the reference image, half of is a solid wall and the other half is glass or curtain wall. We take the measurements directly from the reference image and apply them to the model. Based on the image, we need to add a 3 meters solid wall, starting from the right side and then the windows beginning after that. For the next step, we move on to modeling the floor box on the same floor. We take the dimension from the reference image and this time we check the distance. From the left side of the balcony, reach approximately 2.5 meters. I select some new components, then choose the floor of this level and set the work plan on it. I pick the starting edge of the balcony and offset it by 2.5 meters. After that, I draw the remaining line for the flower box, confirm the sketch, and set its height and extrusion. Finally, I adjust the extrusion start to control the distance from the floor. In the next step, we model the handles and flashing using new components and extrusion. Since there's no specific or advancing training point in this part, we move it through it a bit faster and jump into the more exciting stage next. In this step, instead of using extrude, we use the bevel tools to model the balcony edge profile. First, we need to define the bevel path. We can either draw the path or pitch it directly. And then refine it using fillets or trim if needed. Once the path is final, we confirm it. In the next step, we create a profile section for the bevels. If you look at the reference image, the profile has a U-shaped form. We create a profile section for the bevel. From the profile, edit profile, we draw the section directly on this path. You can draw any profile section you want, and that profile will follow the defined pattern. You can even add as much detail is needed to the section. However, in this case, we are keeping it simple and matching the U-shaped profile shown in the reference image. After drawing the profile, we confirm it, and with the final confirmation of bevel, the geometry is created. At this point, it looks like the main elements of the projects are already in a place, and the model is very close to the reference image. We can now move on to adding more details. We probably speed up the video while adding the remaining details because there are nothing new to explain and we are using the same technique we already learned. This helps us to get to the more important and interesting parts faster. Of course, if anything important come up, I explain it along the way. To import an architecture project or facade design from Revit into D5 render, proper material assignment in Revit is required. D5 does not read the object by their geometry. It only reads the material. This means elements with the same material will be selected together, and different material can be controlled separately in D5. Revit materials do not need to be realistic or final. They mainly work as a label to define how elements are separate during rendering. If materials are not assigned correctly in Revit, controlling and adjusting them